Okay, so we'll continue this second part by solving examples from the homework to understand this transition. So of course, 2.7, so for this first one, we did something similar here, and previously we had to say t equal 1 and, and pick t equal 2 and 1.5 and so forth and make a table and see where that goes. Then I introduced the two parts in solving, and you can use both of them here. And then I talked about mostly if we try to take the limit of that slope or that difference quotient, and here of y, we can go ahead and describe a as a, or here as 1 because that's the question. So 1 plus h minus y of 1 over h, and which would be 38 1 plus h minus 16 1 plus h squared minus y of 1. Y of 1 is 38 minus 16 over h. Okay, then distribute, and we FOIL this one. Remember the shortcut. It's this plus 2 times both and this squared. 2h plus h squared. All right, and minus 16 there. Okay, so 22. All right, and h, so 38 minus 22 will give us that 16, right? 16 plus 38h minus 16 minus 32h minus 16h squared over h, and all right, 38 minus 32 is 6. Then we simplify the h, cancel it. Let's show it here just in case. So this is kind of the formula, right, for that derivative there. But at 1, all right, so now you do the direct substitution and you get a 6. Okay, so of course if we go back to the units, feet per second, they're written this way and sometimes it's written this way as well. So this is the instantaneous velocity when t equal 1 for this ball that is thrown and it's following this position function, right? All right, so now we're going to talk about number 2. Give you a second there to go through it. If a rock is thrown up or you see, so it's like you've seen this before, and we're going to do this now with the the new information that we have. Okay, so for A, if you've done previous homework, you're familiar with this type of problems, and if you looked at what we did, you know now what's up. So we're going to just do the same thing again and just reinforce this scale. Here I will just go ahead and say the velocity after 1 second means we are interested at 1. So again, we're going to set up that limit, and here it's h of 1 plus h and minus h of 1 over h. So we'll do this separately, just like we just did. So 15 1 plus h minus 1.86 1 plus h squared minus h of 1, so 15 minus 1.86. And I'll pause the video here and give you, or probably you also should probably pause here and write down and then see after this whether you're coming up with the same thing. Because that's the purpose from these drills, is to be able to these algebraic process. Okay, so if you did it, you should get something like this. Then we do 15 and 13, 14, 1.86 and 15h, and distribute, right, 372, and of course you keep watching for the signs. And these cancel, and for the h's we get 11.28 h for this one and this one, and we get all right. So 11.28h with the h cancels, minus 1.86h as h approaches 0. And with the direct substitution, so for A, it's 11.28. Okay. And for further practice, now B asks for t equal A. So the velocity t equal A. So we're going to do the same work except for 1. We'll use A. So we could have done B first, then put in 1 for A would be better. But I'm just following how the example is. But if it is, my way of doing it, I'll go for B first and use A. But it's fine as we're practicing a little more on this thing. Okay. So think about the start and try it. Right, so we do the limit again. And now it's A plus H minus H of A and H. And so hopefully you paused the video and tried this, and now I'll go ahead and put this parts. So let's just do this part first. So the 15 now takes a plus h minus 1.86, and it takes a plus h squared, and that gives us 15a plus 15h minus 186, the a squared plus 2ah plus the h squared, and so the 15a plus 15h minus 1.86 a squared minus 372 ah minus 186 a squared. So we did this one, now we do this one, ha, which is substitute a into the y function, a squared. Okay, so subtracting these two, right? Subtract as requested in the numerator. We're gonna have 15a with 15a. Let's see. Okay. Yeah, so this one has to become a plus. So it is minus, but when you subtract, it's going to become a plus. All right, so because it's 15a, so if you write all this, right, and you do minus, let's rewrite it here. So 15a, the first one, minus, now you do this one, right, you do 15a, and this minus minus, so it becomes plus 186 a squared. So 15a with 15a will cancel. This will also cancel, and will leave us with 15h and negative 3.72 ah, right? So the top part is going to be 15h minus 3.72 ah minus 1.86 a squared over h, and now the h will simplify, right? And we get the limit of 15 minus 3.72a minus 1.86h, and now with the direct substitution this will become 0, so 15 minus 3.72a. So that's the request for B, which is the velocity of the rock when t, so the velocity of the rock when t equal a, and of course with in meters per second. So now we look at the next request. When will the rock hit the surface? So this is more of an algebra problem, because when the rock hits the surface, h is going to be 0 here. So we will use that for the formula. So 15t, let's stay here. Will equal to 0 because h is going to be 0 at that point. So we can factor t, and it's either t equals 0 with the 0 product property, or 15 minus 1.86 t equals 0. That's the initial time. So we want later on when it hits the surface. So we'll solve for this, and t will equal to 15 over 1.86, but it's going to be negative. Right, so if you add 1.8, no, it's still going to be positive here, because you do 15, 1.86, t time has, of course, to be positive. But when we use it into the velocity, it's going to be negative. Okay. Yeah, I move a little faster on this. So it's t, 15 over 1.86. Time must be positive, of course. If it comes up negative, means incorrect, and we have to double check what's going on. But now for the next request, of course, because of the direction, with what velocity will the rock hit the surface, we have the formula. So that's what we found, velocity, right? At a given A, it's 15 minus 3.72 A. So now for D part, the question is, what is the velocity when it hits surface, which means this number here, 15 over 1.86. Let's see what that is, divided by 0.6. Yeah, so it's a big number that needs to be rounded. Depends on how you're asked to round, right? But that's why I'm going to use the original value, 15 over 1.86 here, because this is not an exact value. It has to be rounded. So for C, you probably asked to round to a certain value. But when we come to D, let's just say this and apply it, and 15 minus 3.72, 15 over 1.86, and find out what that is. So it's 15 minus 30, which is negative 15 meter per second. Okay. Yeah, of course, the velocity, as you see, just like the slope, the rate of change, it could be going up positive, coming down negative, right? So in this case, it is expected to come up negative. So for this question, find an equation of the tangent line to the graph g of x at x equal 4, so that a point is 4. If g of 4 is negative 3, so what does that mean? It means this. There is a point at the function g, or at the graph, it's for negative 3. And g of prime of 4 equals 6 means, kind of the slope at 4 is 6. So if you watch the beginning of the video talking about how to find this equation of a tangent on a simple problem, we will use that now here. So so y minus y1, or f of a, or g of a here, equal the derivative at 4. So just to show you based on the formula, which is a 6, x minus x1, which is a 4. So that's kind of that formula. So y plus 3 equal to 6, x minus 4, 6x. Then we subtract 3. This would be the tangent line on this curve g of x at that point of 4. If the tangent line, this is number 5, to y equal f of x at 5, 2, passes through the point 0, 1, find f of 5 and f prime of 5. So here what we're doing is trying to connect now this, advancing a little bit in calculus with the previous algebra, so we can connect between this tangent and the slope and the derivative. So kind of think about it, 2 points, 5, 2, and let's say, I'm not doing to scale here, let's say 0, 1 or something, just so you know. You've seen a picture like this, it means you need to find the slope, right? And once you find the slope, it's going to be at that point there, f. Okay, so let's remove this now that the idea is clear. So f of 5 is 2. That's already given, even though it's asked there. So this is going to be the slope, which is that 1 minus 2 over 0 minus 5, which is -1 over -5, which is 1/5.